Hi guys, this is our second lecture on the matrix. Today we have find our A inverse in these numerical problems. So let us start the problems. We know that A inverse exists when that A not equals to 0 means non-singular matrix. And our inverse formula is A inverse equal to adjoint of A by determinant of A. At first we have to find out the determinant of A. Determinant of A equals to determinant of the elements in the matrix 1, 2, 3, 1, 3, minus 1, minus 1, 1, minus 7. If I break down along the row wise, 1 into 3, 1, minus 7, then minus 2 into this row and this column, removing 1, minus 1, minus 1, minus 7, 1, minus 1, minus 1, minus 7, then next element plus 3 equals to this row and this column, 1, 3, minus 1, 1, 1, 3, minus 1, 1. Now we have to solve this line. 1 into minus 27, minus 21, sorry, minus 21 and minus of minus 1, minus 2 into minus 7, minus of minus 1 into minus 1 plus 1, plus 3 into 1 minus minus 3, minus 21 plus 1 means minus 20, minus 7 minus 1 means minus 8 plus 16, plus 1 plus 3 4, 3 4s are 12, 16 12 28 means our determinant value is 8, so which is not equals to 0, so A inverse exists. Now we have to find out the adjoint of the A matrix. So adjoint of A equals to, this is our 3 by 3 order of matrix, so adjoint of A equals to, it also becomes 3 by 3 order of matrix, and the transpose. Here first we have to give this is plus, this is minus, this plus, minus, plus, minus, plus, minus, plus. Here we have to write the cofactor of this first element 1. So with respect to the respective row and respective column of the one element, our cofactors are 3, minus 1, 1, minus 7. Similarly for 2, this row, column and this row become 1, minus 1, minus 1, minus 7, 1, minus 1, minus 1, minus 7. For this row, for 3, 1, 3, minus 1, 1, 1, 3, minus 1, 1. For 1, 2, 3, 1, minus 7, 2, 3, 1, minus 7. For 3, 1 3 minus 1 minus 7, and for this means second row and third column, this and this becomes 1 2 minus 1 1, 1 2 minus 1 1. For third row, this element with respect to this respective row and respective columns, 2 3 3 minus 1, 2 3 3 minus 1. For this element, 1 3 1 minus 1, 1 3 1 minus 1, and for this 1 2 1 3, 1 2 1 3. Now we have to solve this. 3 into minus 7, 3 into minus 7, minus 21 minus 1. Then the second element, minus 7 minus 1. And for the third element, 1 minus 3. Here I give the transpose. For second row, minus 14, minus 14 and minus or plus minus 3. For this, minus 7 minus 3, 1 minus 2. For third element, for this row, minus 2 minus 9, minus 1 minus 3, 3 minus 2. Now we have to solve this. Minus 21 plus 1 means minus 20, minus 8 and minus of minus 8 means plus 8. Here 1 minus of minus 3 means 1 plus 3 4, and minus of minus 14 minus 3 means minus 17, and minus 7 plus 3 minus 4, 1 plus 2 3 minus 3, minus 2 minus 9 means minus 11, minus of minus 4 means plus 4, and here 3 minus 2 1. Transpose. So adjoint means adjoint of A. So adjoint of A equals to minus 20 removing the transpose sign. So all the rows elements and the column elements are interchanged. 17 minus 4 minus 3, and the third row becomes to the third column, minus 11 4 1, and our order is 3 by 3. This is our adjoint. Now we know that A inverse equal to adjoint of A by dat of A. So our adjoint is this matrix and our dat is 8. So 1 by 8 of minus 20, 8, 4, 17, minus 4, minus 3, minus 11, 4, 1. This is our answer. And our second question is to solve this linear equations. Here a equals to 1, 2, 3, and here if we see the equations, given equations, so all the x coefficients of x of the three equations are same, 1, 2, 3, means these rows elements are here. So if we express these three equations in matrix, 2x plus 3y plus z equals to 10, 3x minus y minus 7z equals to 1. Our a is a equal to 1, 2, 3, 1, 3, minus 1, minus 1, 1, minus 7. Let us A transpose into x equals to b, where A transpose equals to 1, 2, 3, 1, 3, minus 1, 1, 3, minus 1, minus 1, 1, minus 7. And our x is x, y, z. It is 3 by 3 matrix, it is 3 by 1 matrix, and another our b is b equal to this right hand side elements 3, 10, 1. It's also a 3 by 1 element. So 1, 1, minus 1, 2, 3, 1, 3, minus 1, minus 7 into x, y, z. Let us see 1 into x, x plus y minus z equals to 3. Our first equation. 2x plus 3y plus z equals to 10. See, 2 into x plus 3 into y plus 1 into z equals to 10. So it becomes our second equation. And the third equation, similarly 3x minus y and minus 7z equals to 1. Now, so x equals to A transpose. If I write this on the left hand side to right hand side, so given the inverse sign of b into b. Here there is one property of transpose. A transpose inverse equals to A inverse of transpose. So A inverse of transpose into b, and our inverse results of our inverse is 1 by 8 of this matrix. So here I write this matrix 1 by 8 of minus 20, 17, minus 11, 8, minus 4, 4, 4, minus 3, 1. Here there is the transpose sign, so I give the transpose sign here, and into b. B means 3, 10, 1. So 1 by 8 of minus 20, 8, if minus 28, 4, 17, minus 4, minus 3, minus 11, 4, 1. Removing the transpose sign, 3, 10, 1. So here matrix multiplication is possible, since it is our 3 by 3 matrix and it is our 3 by 1 matrix, and our results is 3 by 1 matrix, which is the order of the x, y, x matrix. 1 by 8 of minus 20 into minus 3 means minus 60 plus 80 plus 80 and plus 4, 24. Next 17 into 3, 51, minus 40 minus 3 means 51 minus 3, 48, 48 minus 48. And our third element is minus 33, 10 the 40 plus 40 plus 1. Means 40 minus 33, 7 plus 1, 8. It's equals to, if I divide by 8 on for all the elements, 3 8 is 24, 1 1. So x equals to 3 1 1, and our x matrix is x y z 3 1 1. So respectively x equals to 3, y equal to 1, and z equals to 1. This is our answer. On our next lecture, we will start our next chapter, determinant. So you guys, if there has any problem on the matrix, you may ask in the comment section. Thank you.